Hello, these video notes are about one-dimensional motion, also called linear motion. There are two types of quantities that we use to talk about in motion in physics, scalars and vectors. First, let me back up and tell you what a quantity means. A quantity is something that is measured or calculated, but it's a physics quantity like distance, length, height, speed, time, mass, weight, force. All those things, all those words we use in physics are called quantities. We have scalars and vectors. A scalar is a quantity that doesn't have direction, and a vector is a quantity that does have direction. And both of these have what we call magnitude or amount. The scalar has only a magnitude, 15 meters, but no direction. It has an amount, but no direction. 28 kilometers per second is the amount, but there's no direction. So a vector does have the direction, like north, south, east, west, left, right, up, down, forwards, or backwards. So when an object moves, we have two ways to describe how far it goes. Distance and displacement. Distance is exactly what you think it is. When this bug moves from A to B, it follows this curved blue path. And the distance is the length of that blue curve. The total magnitude traveled, the total amount of length traveled along that blue path. That's the distance. The displacement is how far the bug is from where it started along a straight line, or the shortest distance from the starting point to the ending point. That's displacement. If you're taking a car on a trip from your house to the mall and there's a traffic jam, you may go around the traffic jam following a different path, but to do that you're going to have to increase the distance. But you won't increase the displacement because you're still going from your house to the mall. So the displacement from the house to the mall is the same whether or not you go around a traffic jam. So it's independent of the path. In physics, we also need words to describe how fast an object is moving. Well, that's what speed is, the rate of change in distance with respect to time. In the equation form, it's speed equals distance divided by time. And the units for speed, I'll have four examples of units for speed. Each one of them is a distance slash time, meters slash seconds, centimeters slash seconds, miles per hour, kilometers slash hours. The slash means divided by or per, meters per second, centimeters per second, miles per hour, kilometers per hour. They're all a distance per unit time, or a distance divided by time. In this class, we will mostly use meters per second for the unit of speed. It's in the metric system. We're more familiar with miles per hour, but unfortunately we use the metric system more in this class. Speed is a scalar, which means it does not have a direction. It only has an amount. When you're in your car looking at the speedometer to tell you how fast you're moving, the speedometer will tell you you're going 55 miles an hour, but it won't tell you what direction you're going. There may be another instrument in your car that tells you the direction, a compass, but it doesn't, the speedometer itself does not tell you that. Another word we use to describe how fast an object is moving is velocity. And velocity is like speed, except that it's the rate of change in displacement with respect to time. So it's like speed, except speed uses distance, velocity uses displacement. And that means that velocity is a vector because it has a direction. Since displacement has a direction, velocity will also have a direction. So it's the change in displacement with time. Here's an example of a turtle that's moving with a speed. Now, how do you know it's moving? Well, it says 2 centimeters per second. That's a unit of speed. So that's the speed of that turtle. But this picture shows a different a turtle that has 2 centimeters per second, but it also says west, and it has an arrow pointing to the west, and that arrow represents that this turtle is moving in that direction toward the west. So that means this 2 centimeters per second here is the velocity, which is a vector. The speed doesn't have a direction, it's a scalar. So that's one big difference between speed and velocity right there, is the speed doesn't have the direction where the velocity does. So a couple of questions with math problems in them, like a car travels 1,000 meters in 50 seconds. What is the car's speed? Well, if you remember back to the equation I showed you, speed is distance divided by time. So you take the distance here, 1,000 meters, that's the distance, and the time, 50 seconds, and just divide them. 1,000 divided by 50. 1,000 meters divided by 50 seconds. Well, the 1,000 divided by 50 gives you 20. And the unit comes from meters divided by seconds, or meters per second. How about another example? Here's a car traveling 1,000 meters north. So this right here is a displacement. It traveled 1,000 meters, but it also has a direction. So that's a displacement. And it did that in 50 seconds. So what's the car's velocity? Well, if you look at the equation for velocity, it's the displacement divided by the time. So you take that displacement, 1,000 meters, and divide it by the time, 50 seconds, and you get 20. Now notice again, it's the same answer as this first question. The only difference is that it had the word north, so that makes it the velocity. So in this sample problem, we got a car that travels 500 meters east. It turns around and goes 1,000 meters west, and then it turns around again and goes 2,000 meters east again. And it says it does it in a time of 100 seconds. What is the car's average speed? Well, the average speed is the distance over the time. Now, how do you get the distance? The time is pretty easy, it's 100 seconds. But how do you get the distance? 2,000 meters, 1,000 meters, 500 meters. How do you get the total distance? Well, it's sort of like that bug. If you were to imagine this car, to find the distance, you would measure the total length that the car traveled, which is the sum. You would add these. 500 plus 1,000 plus 2,000 is 3,500. That's the distance. So you divide that by the time, distance over time. 3,500 meters divided by 100 seconds gives you 35 meters per second. Then another question here is, what is the car's average velocity? And we'll tell you about average later. But let's use that formula. Velocity is displacement divided by time. It's not going to be the same number here. And the reason why is because this car is moving 500 this way, then 1,000 back this way, then 2,000 this way again. Because of that, because they're opposite directions, we can't add them up. We can only add those that are the same direction, and we subtract the one that's the opposite. So 500 and 2,000 are both in the east. They're both toward the east, so we can add them together. But then this one is to the west, so we subtract it. So it's almost like saying this is positive, this is positive, no, this is negative, and this one is positive. So 500 minus 1,000 plus 2,000. That is the displacement. The displacement divided by the time. 500 plus 2,000 minus 1,000 is 1,500 meters. So 1,500 meters east, that's the displacement. And you divide that by the time, 100 seconds, that gives you 15 meters per second east. A few more examples. Take a look at this. A football player runs 100 yards across the field. He turns around and runs 100 yards back. What's his displacement? So he's running from one end zone across the field to the other end zone and immediately turns around and runs the whole distance of the field back to his original end zone. What's his displacement? Straight line distance from the beginning to the end. You may have been tempted to say it's 100 plus 100. The displacement is not just where you add up the total length. The displacement is how far you are from where you're beginning. So if he started at this end zone, and here's the other end zone, and he ran all the way down and came all the way back, he started here and ended up here. So his displacement is the distance from where he started to where he ended, which is 0. He started and ended in the same place. So it's a little bit of a trick. What about his distance? Where his distance is just 100 yards that way and 100 yards that way is the total, so 200. Okay, we also use words like average and instantaneous to describe speed. You probably have been in a car and you've looked at the speedometer of the car and it tells you how fast. And you may have been in a car that tells you the average speed. So look at this. You can see here's a car moving 65 miles an hour. But then how could it also have an average of 61.8? What's the difference here? Well, this is the instantaneous speed because it's telling you how fast the car is going at that moment. But usually in a car, it doesn't stay at the same speed. It can't forever. It has to eventually change speed. It's got to start, it's got to stop. And you might go on a long trip where it stays at 65 for a long time. But eventually the car's got to change speed. So that's why we use words like instantaneous and average. The average is simply just the total distance divided by the total time. But the instantaneous is how fast that car is going at that moment. All right, we're going to do a few more practice problems here using the speed equation. But what we need to be able to practice here is we read a question. A dog runs 15.3 meters per second for 32 seconds. How far does he go? Well, we need to know what these numbers actually stand for. This is the speed. Now, how do I know that? Because it says meters per second. This is the time, because it's 32 seconds. This is a unit of speed. This is a unit of time. So I know that this is the speed, that's the unit of time, and that's the time. Now, the next thing is how far. Well, how far he goes is distance. So here what I'm trying to do is calculate the distance if I know the speed and time. I'm going to end up multiplying the speed times the time. When you need the distance, you multiply speed times time. So 15.3 times 32. 15.3 times 32 gives me 489.6. 489.6 is the distance, and the unit of that is meters. So that's how far this dog goes. How long does it take to go 12 meters in a car traveling 28? 12 meters, that's distance, because it's meters. 28 meters per second is speed, because of the unit meters per second. So now I'm trying to find the time. To get the time, you have to actually divide the distance by the speed. Time equals distance divided by speed. So the distance is 12. The speed is 28. And 12 divided by 28 equals 0.42, I want to round it here, 0.429. And because it's how long, how much time, that's in seconds. Be careful with questions like this because you're tempted, a lot of students are tempted to take the big number and divide it by the small number. But in this case, what you got to do is follow the equation. I'm trying to find the time. I got to do distance divided by speed. And that gives me the time, 0.429 seconds. And this last one, what's the speed of an airplane flying 2,000 kilometers for 2.5 hours? Well, first thing, 2,000 kilometers. That is a distance. 2.5 hours is a time. So I've got a distance and a time, and I need to find the speed. What is the speed? Well, the speed will be the distance divided by the time. Distance divided by time. 2,000 divided by 2.5, which is 800. Now, we have to be careful about these units because I've told you units of speed are meters per second. That's what they are, and that's the unit and the speed in this question, and the unit of the speed in that question. But here we got to be a little more careful. Look at the unit of distance, km, kilometers, kilometers. And what is the unit of time? Hours. So you have to make the unit of speed from those two units. So instead of meters per second, it's going to be km, kilometer, per hour.